At this point in the semester, you should be starting to feel very comfortable coding in Java with IntelliJ. In this video, we'll be showing you how to use the IntelliJ Debugger tool so that you can become a better debugger. Let's start first with what even is the IntelliJ Debugger. A debugger is a program that allows you to step through your program one line at a time to identify how a program flows. So far, we've encouraged you to add print lines into your program to identify and solve your bugs. While using print lines is one strategy that works great in some situations, a debugger is much more effective at finding bugs by allowing you access to a lot of information about your program while it's running. Starting during Doodle Jump, the TAs at debugging hours will often have you use the IntelliJ Debugger tool to find your bugs, so you should be familiar with using it on your own first. In this video, we'll use code from Andy's Alien Mover example from lecture. I've tried to type up the program and run it, but right now it's not working like I'd like it to. So let's use the debugger to fix it. This code is posted publicly on GitHub, and the link to the repo is in the video description. You should follow along with the video to practice using the debugger, so go ahead and pause the video now to clone the code. Great. Once you have the code cloned, we can get started with the demo. So we recently learned that IntelliJ can help compile and run our code in one step using the play button. So let's try it out with this program and see what it looks like now. So let's run app. It looks like we're getting a runtime error. A useful tip when trying to decipher these errors is to start at the top of the error and look line by line until you see something that looks familiar. So if we start at the top, not much of this makes sense, but then we see a null pointer exception with the error message that the child node is not null. And if we keep looking down, we see alien.java line 16. If I click this right here, it'll take me to that line. So the null pointer exception is coming from when we add our nodes into the pane. Based on the error message, I'd guess that one of the nodes is probably null when we try to add it. You might see the issue right away, but let's practice using the debugger to find it. So to use the debugger, we set what are called breakpoints in the program. As the program is being executed in debug mode, when it reaches a breakpoint, it stops execution so that we can inspect the state of the program. Since my issue is at line 16, I'll set a breakpoint on the line above, line 15. So to set a breakpoint, first you find the line at which you want to set a breakpoint, so here line 15. Then come to the left side near where the line numbers are, and click the empty area to the right of the line number. You'll see a little red dot appear. So that red dot indicates a breakpoint. We can toggle any breakpoint by clicking the dot again. So let's add the breakpoint, and let's see what happens when we run our code with the breakpoint. So far, we've just been using the run button, but in regular run mode, IntelliJ won't stop at breakpoints, like this, if we try again. So it didn't stop at the breakpoint. Instead, we can use debug mode, which is the bug icon to the right of the play button. Just like you can run the code from the play button in app, you can also run debug mode from here. So let's try that. Let's do debug app.main. When the debugger reaches a breakpoint, all the information about the current state of the program pops up in the debugger window, this window down here. There is a lot of information for us to use here. So much more that can be told with a single print line. Notice, for example, it lists all of the instance variables in our class, as well as local variables in this method, with extra information about each. For example, it shows us that the left eye currently has center x 0 and center y 100, etc. You can also click the arrow to the left of the variable name to get even more information. Most of this probably won't be necessary for us, but it's worth poking around just to see what we can learn. So we can close that up. So we've stopped execution, but what's most powerful about the debugger is being able to control the step-by-step execution. So these arrow buttons at the top of the debug console allow us to follow the flow of control to see how the program changes. Right now, we'll use this far left button with the arrow, the bent arrow up and down. And this button means to step over the next line of code. So right now we're stopped at line 15, meaning line 15 has not quite executed, but will execute very soon, once we tell the program to take a step. So the line that's currently highlighted initializes the right eye. So what do you think will change in the debugger console when we let that line execute? Let's see. So we press the step over button. As you might have expected, now we see that the right eye is no longer null and we can examine its properties as well. So the next line, line 16, again, that has not quite executed but will, once we step over, is the line where we had our null pointer exception before. And if we look at the debugger console, we can see why. The right eye and the left eye have been initialized, but the face instance variable is still null. So if we step over that line again by clicking this button, we'll again see, and we can move to the console, we get the same error with the null pointer exception. So we can add this line right above to make sure we initialize the face. Face equals new ellipse, and we'll use our predefined constants for the face radius x and face radius y. So let's try running the program now. Yay, the window appears. Now let's try seeing what happens when we use the buttons. So nothing seems to happen when we try to move the alien. So we have no runtime errors anymore, but it seems that we have a logical bug in our code, so it's not executing as we'd like it to. So let's use the debugger again. Now we're done with this breakpoint, so we can toggle it off. Because this new bug is a logical bug, we don't have a specific line to set a breakpoint at. So where should we add a breakpoint? Well, our issue now is that the reaction to the button click event is not working. So let's check out the move handler in the alien mover class. With print lines, to debug this, we may add a print line to the handle method to see if it's ever called. With the debugger, we can use a similar strategy. By adding a breakpoint in the handle method, we'll see if the program ever reaches that line to pause execution. One great feature of the debugger is that you can dynamically add and remove breakpoints while running in debug mode, so let's try that out. Right now we have no breakpoints, but let's run in debug mode. Our window's popped up, and now let's add a breakpoint to the handle method. Right now, again, like we had before, nothing happens when we press the buttons. So we add a breakpoint in the handle method. What I think should happen is that whenever I press a button, the program will try to execute this line like I think it should, so the program should pause into the handle method. Let's see. So when I press the buttons, still nothing happens. So since the program didn't pause at the breakpoint, that means that line of code isn't being called at all. So that seems to indicate we never told the buttons to activate the move handler on click. And if we look above, we do in fact see that we never used the setOnAction method for the buttons. So let's add that now. We'll stop execution and add the code. So for B1, we have move handler true, so it's is left. And for move handler 2, for button 2, we have move handler false for not left, it's right. Okay, so let's see if that works now. So if I run it, amazing. So now it's moving right. And we notice, however, if we click left, it also moves right. So that's weird because I was positive that I said is left is true for the first button and is left is false for the second button. So again, we have another logical bug here rather than a runtime error, like the first bug. So let's use the same breakpoint to see what's wrong. So right now we're running in play mode. So now we'll run it in debug mode again, and we'll use the same breakpoint set here. So when I click one of the buttons, it should have us pause into the handle method. So when I click move right, and it seems to work, let's check out the program state. Great. So it pauses execution right there. So if we look at the event, it does seem to indicate that it was triggered from the move right event, and the distance to move is 10. That all sounds great. Now let's see what happens when we click move left. To let it activate again, however, we have to move on from this breakpoint, so we'll let the program resume execution by clicking the green resume button on the left side of the debugger console. So we'll resume it, go back into our program, and now let's do move left. So again, as expected, the event says it was triggered from move left button, but the distance is 9 instead of -10. So that's why it must be moving to the right. How did this happen? For some reason, the distance instance variable was configured incorrectly. So let's compare how the move handlers are configured. You may see the issue now, but we'll learn another debugger trick to pinpoint it. So far, we've only used this arrow button on the left to step over code, but we can also use the button to its right with just a down arrow to step into code. So stepping into code means that the debugger will take you into a method call to see what's happening. So let's see an example by putting a breakpoint in the first line of the alien mover constructor. And then let's rerun in debug mode. So I can rerun with this button. So we've stopped at line 14 of the alien mover. And we know that if we press the step over button, it will initialize the alien instance variable and move to line 15. But let's see what happens if we press step into. So now it takes us into the constructor for alien, which is the next code that will be executed. So from here, we can continue stepping over these lines of code. And once we reach the end of the method, if we press step over again, it takes us back to where we were before in the alien mover constructor, and then we can move to the next line. And now we see alien has been initialized. So let's see another example by stepping into this setup buttons method, the call to this.setupButtons. So again, it took us into the method call where we can continue execution. Now be careful with stepping into code, because if you try to step into a call to a method that you didn't write, it will show you that code, which can get very confusing. So for example, let's step into this line here to see the JavaFX button constructor. Okay, so it gave us this whole weird thing, which probably wasn't quite what we were expecting, and we do not need to understand this. So instead, we can click the up arrow for step out until we return to the setup buttons method. Great, we're back, and we can close out of all these files. We don't need to know what's going on there. It seems quite confusing. So now let's return to the issue we're having with the distance. So let's step into the move handler constructor to see where the logical bug is. So we'll step over until we reach this line. So notice that this line of code actually has two nested method calls. So the inner call is to the move handler constructor, and the outer call is to the setOnAction method. So when you try to step into a line with multiple method calls, IntelliJ will let you choose which method to step into. So I'll click step into, and it won't quite step into. It'll highlight in pink the two different method calls, and we can choose. So we can use the right and left arrow keys to pick one, and then click again, or we can just click on which one we want. So I'll click, I want move handler to step into that. So now we've stepped into the move handler constructor. And this is, we can see isLeft is true. So this is when we're configuring the left move handler. So first, let's see what happens. So we'll step over, we initialize distance, and it is 10. We can also see that in the window, it also gives us information that's helpful as we go. So distance is 10. We can also see that in the console. Then, since it is moving to the left, so we will step there. So now we see we add -1. So once we add -1, that's where we're getting 9. So it seems like this was a mistake where we wanted to multiply by -1, but instead added -1. So let's fix that and try again. So we'll stop. Let's do times equals -1. And let's see what happens. So if we move right, it's working perfectly. And if we move left, it now works. Yay! So now our program is working just as we wanted it to. Before we're done, we want to show a few more features of the debugger that will come in handy. So to do this, let's add a breakpoint in the aliens setXLocation method on the first line. And then let's run in debug mode. So the first extra feature is the Debugger Evaluator. So the main Debugger Console here gives us a ton of information, but sometimes you still may want more. If we click this calculator icon, it opens the IntelliJ Debugger Evaluator, where we can type and enter any expression to see its return. For example, I could type 1 + 2, that gives us 3, or I could do something like math.random, gives us different results each time I click enter. More likely though, I may want to see something like, in this scope, we have, so I actually didn't go to I forgot to turn this breakpoint off. So let's resume until we make it. Now we're at this breakpoint in the alien class. So in this scope, I have access to the face instance variable. So maybe I would want to say face.getCenterY, which gives us 130, or maybe I would want to say face.getFill. So as you can see, it gives us a lot of information. And let's see, if we step out to a scope where we have access to a pane, so here we have access to the alien pane, we can use things like alien pane.getChildren. You can see all the children in there. Or we could do button pane, .getAlignment, something like that. So the evaluator is a very powerful tool that you should take advantage of. So similar to using the evaluator, we may want to see how a value changes over time throughout the program. So if we close out of the evaluator, we can use this plus button to add a watch to track a value throughout execution. So maybe I want to make sure the buttons are properly added to the button pane. So I'll add a watch for button pane.getChildren. So right now we have no children, 0. And maybe if I step into setup buttons, still 0. And if I keep going, once I add the children, now I see our watch for button pane.getChildren is 2. So you can also take advantage of using watches to track a value over time. So the last feature we want to showcase is setting a conditional breakpoint. So let's say you have a bug that only occurs when the alien moves off screen left. So I could add a breakpoint in the handle method and hit continue in each time until the alien is off screen like this. So I'll get rid of that one, get rid of the watch, make sure that our only breakpoint is in the handle method. So I could run it in debug mode, and I only care when it's off screen, so I do move left, resume, move left, resume, etc., until it reaches the left. Or I can set a conditional breakpoint so that it only pauses execution at that breakpoint when the alien is off screen. So to do this, set a breakpoint anywhere. I already have this breakpoint set on line 38. Then right-click the breakpoint and then type in any condition. So in this case, we'll use alien.getXLocation, and we want to make sure to take into account the constants.faceRadiusX, and we'll do whenever that's less than 0. So only when it's less than 0 do we want this to run. So now when we run, it only pauses the breakpoint when it's off screen. Wow. So we've covered a lot of features of the IntelliJ debugger now. So while print lines are still a good strategy, for debugging sometimes, taking advantage of the debugger will prove much more effective. One of the main powers of the debugger over print lines is that with each print line, you're merely taking a guess at the bug, and then you have to rerun each time with a new guess. However, with the debugger, you can examine so much information at once and without having to rerun the program, so that you're able to pinpoint errors much faster. It will take some practice to get used to using the IntelliJ debugger, but by the end of the semester, using this tool will save you a lot of time solving bugs during Doodle Jump, Tetris, and final projects. If you have any questions about using the debugger, come to conceptual hours or sign up for debugging hours and we'll help you out. Or post on Piazza. All right, good luck.